Greetings and welcome, my dear students. I'm glad to have you here for another episode, the second episode on the series of Arithmetic of Finance. Today, we're going to be looking at compound interest, and it is my optimal desire that by the end of the class, you should be confident enough to solve problems on compound interest. All right, so let's quickly go to the classroom and see what we have there. All right, compound interest. All right, in the first episode, we learned about simple interest. Okay, contrast to the principle behind simple interest, where the interests are usually added or credited to the beneficiary at the end of the agreed time. It might be weekly, it might be daily, it might be monthly. Okay, what happens here, similar to what's obtainable in banks. Every month, the bank will send an alert to their customers. Okay, so in that case, the bank have decided to make or to have a monthly agreement with their clients. All right, so but in compound interest, you don't receive a credit alert for the interest that you have made. Okay, so in compound interest, the interest is automatically added to the current principal. Let's say, for instance, you invested $100, all right, and on 10% interest. Okay, now at the end of each month, 10% interest per month, all right. So at the end of the first month, you're supposed to have 10% as your interest, which is about $10. So if it was in simple interest, you'll be given $10 alert for that particular month, for after 1 month, while your principal, the initial amount of money invested, will still be with the bank or the person you invested, you did investment with, all right, till the end of the agreed time. So they keep on giving you interest, crediting your account every month because the agreement is monthly. The rate is 10% monthly. If it was 10% yearly, they'll be giving you $10 every year. All right, so that is for simple interest. But in compound interest, at the end of that month, instead of them to credit you, they will not credit you. They automatically add it to you, the $100 you invested, to make it $110. This will now increase the amount of investment you have with them. So it's no longer seen as if you have $100, but now you have now invested $110 with them. So that is why I mentioned earlier in episode 1 about active principal. So your active principal is no longer $100, but it's now $110 at the end of the first month. So that is what they are going to use now to calculate your net profit for the second month. So this process continues to the end of the agreed time, when the total amount is now returned to the beneficiary. And what is the total amount? Remember, you are only credited once under in a normal circumstance in compound interest. Okay, in a normal circumstance of compound interest, take note of normal circumstance, you are credited only once. All right, and that once you are given all the money that is due unto you, both all your profits and the amount of money you invested. So that is why we now have a formula for the compound amount, which is P into 1 plus R all raised to the power n. So this particular expression there in the bracket repeated a number of times depending on the number of period or the number of reckoning time that you had with the bank. All right, so that is what the amount is. So the amount is your interest, or the total interest plus the initial amount of money you invested. While in simple interest, you keep on receiving interest every month or every year, as the case may be. Then at the end of the agreement, they return the last interest plus the initial amount of money you invested with the person. So you can see the difference between simple interest and compound interest. I'm making this illustration, this explanation, because you might need it in solving problem. And I also made mention of a normal compound interest. There are some compound interest whereby you can also credit the beneficiary in between. Those are conditional compound interest. And so for you to solve that one, you need to analyze it period-wise according to the condition that is prevalent on each period of investment. All right, so this is the formula, and this formula is used when N and R are compatible. What do I mean by compatible? The unit of N, of your N and your R must be compatible. All right, it means that if the rate is given in per annum yearly, your reckoning, which is the number of, which is your N, the number of periods, must also be in years. Using the principles of uniformity in mathematics, you must unify your units so that they can be compatible. So if your N is in years, your rate must also be in years. So if they gave you your rate, but for instance, they gave you 12% per annum, and they say your N, your account is being credited every month, as banks normally do. They credit your account is credited every month. That means you cannot use 12% to solve, because the rate here is in per annum, while your N is in months. So all you need to do, you need to convert this rate also to a monthly rate by dividing it by 12, since there are 12 months in a year. So you can get the rate for 1 month. And you now use the rate for 1 month with the N, your reckoning, which is taking place every month, and now solve. All right, so that's what I mean by N and R being compatible. All right, so your A has been explained, and P is the original principal. So know the use of this formula. Your R is constant. This is the R percentage rate throughout the agreed period, and P is the original principal invested, and N is the number of reckoning on periods. All right. So, but when the rate is changing, if the rate is changing, assuming you have a situation where the rate is not constant, maybe for the first year you invested, it is 10%. The second year you invested, it is 15%. The third year is 20%, but it is compounding. Remember, when you examine this formula, this N from the knowledge of indices means that 1 plus R over 100 is times in itself a number of times, which we don't know, and we call it N. Okay, it is times in itself, just like when you have X multiplied by X, you have X squared. Okay, but when that X repeats a number of times, X multiplied by X, and you say T, the last one, you now say it's X raised to power N. Okay, because the X are all the same. All right, they are all the same, they are not changing. But assuming they are changing, assuming the first one is X1 and the second one is S2, of course, I cannot have it as S squared. If you have X1 multiplied by X2, of course, your answer will give you X1, X2. So because the X are changing, all right? So also, if the rate is changing, it implies that this expression we have here will be used differently for different T. That means you're going to have rate 1 for the first one, 1 plus arrow 1 over 100 for the first year in use in solving. So that's what we have here. So when the rate is changing, this is what you're going to have. Instead of one of the expression raised to power N, you now have the expression, a multiples of the expression with different rates. Arrow 1 for the first reckoning, arrow 2 for the second reckoning, arrow 3 for the third reckoning, and so on and so forth. All right. And the third condition we can have under compound interest is a situation where the condition of investment neither obeys that of equation 1 or equation 2. When it obeys neither equation 1 or equation 2, please solve the question period-wise. That means for each period, if it's the first month, you solve the answer for the first month. If it's for the second month, you solve the answer for the second month, so you can be able to account for all the conditions that are taking place in that question. All right, so we're going to see all this illustration in the following examples. All right, example 1. Let's look at this example solution. Okay, so we are told that a man invested £2 million in a trading company that offers a monthly interest rate at 5%. Okay, this is 5%. All right, and we are told that we should, this is 5%, it's a monthly interest, all right, or 5%. Now, the rate is a monthly interest. All right, so question A. So what are we asked to calculate? If invested for 3 months, simple interest for 3 months. So our N here, all right, our N is equals to 3, which is equals to T, okay? And what do we have again? Our P, okay, the capital he used investing is 2 million. All right. And what do we have again? We now have our rate. Our rate is equals to 15% monthly, okay, per month. So that's what we have. You can see that since our end is also a month, they are compatible for the simple interest. You can use them in simple interest also, just as we learned. So we now use the simple interest formula because we are told that if invested for 3 months simple interest, calculate his total interest at the end of the 3rd month. All right. So we use the simple interest formula here. So we now have our simple interest, okay, is equals to PTR, all right, divided by 100, and that will give us 2 million, which is 2 times 10 raised to the power 6, okay, multiply by 3, multiply by 15, okay, divided by 100. And of course, when you simplify this to your calculator, you have 900,000 pounds. All right, so that will be the answer. Okay, so question B. And what is question B? Question B says, if invested for 3 months, all right, no longer simple interest, but compound interest, calculate his total interest at the end of the 3rd month also. So here we have our R, okay, our R is equals to 15% per month. So it's taking place monthly, that is the reckoning. Our N is also 3 months. The number of reckoning time they will do the 1st month, 2nd month, and 3rd month. And our P is also the same thing, which is 2 million. Okay, so if we use our amount, if we use our formula for compound amount, which is A, is constant, and the rate is also constant for the entire 3 months. So we have this, the case of equation 1, that implies that our A is equals to 2 multiplied by 10 raised to the power 6, which is 2 million for P. 1 plus our rate is 15 over 100 raised to the power 3. Okay? And of course, when you solve your bracket first, which is going to give 1.15 raised to the power 3, then times 2 million, of course, you end up having the amount. The amount now will give us 3,041,750 pounds. So this is what we are going to have as the amount. Hope this is simple enough. Now, but I'm not going to the interest. This is the formula for the compound amount. They ask us, always make sure you read your question clearly. They ask us to calculate his total interest at the end of the month. All right, so this is what I was explaining. So this is what they now return to the man. They credited the man once with the total amount. So his principal is here, his total interest is here. So we now say that implies that amount is equals to his principal plus his interest. So that implies that his interest is going to give us the amount minus the principal, and that will give us 3,041,750 minus 2 million. And of course, we have his interest compounded from compound interest to give us 1041. So we have it as 1041,750 pounds. So this is the money he made from compounding, which is higher than the money he made from taking a simple interest. So do you see the essence of compounding your interest? Calculate the positive difference between the interest type above. So of course, positive difference, bigger one minus smaller one, that's what they mean by positive difference, so that you can have a positive answer. So positive difference, okay, will now give us 1041,750, all right, minus 900,000. Okay, when you solve this, of course, this is what you have, 750 as the final answer in pounds. All right, so this is the analysis of question 1. I hope it's clear enough. Let's look at example 2. It says a saver deposits 240,000 naira, all right, in a bank which pays compound interest at 9.5% per annum half yearly. 9.5% per annum half yearly. All right. So what is the meaning of this statement here? 9.5% per annum half yearly. All right. So that statement here implies that the rate, the yearly rate, okay, the yearly rate is equals to 9.5% per annum. This is the yearly rate, okay, which is anything as 19 over 2% per annum, okay. But we are told there's a statement here attached half yearly. So what does that half yearly imply? It implies that the account of the saver, okay, is being reckoned every half a year, 0.5 year, or every 6 months. Okay, and if that is to be the case, it means that you cannot use the interest for the entire year to be calculating the interest. You cannot use the rate for the entire year to calculate the interest for half a year. So you need to convert the rate for entire year to the rate for half a year, 0.5 year, in order to be able to use so that they can be compatible. All right. So that is the implication. So we cannot say, so in some textbook you might see it can also be in this other way. This statement here, 9.5% per annum half yearly, can also be given to you as 9.5 per annum reckoned half yearly, or with interest reckoned half yearly. So that's another way they can give you that statement. All right, so now we understand that. Can I say half yearly rate? All right, so can I say that implies that a half yearly rate now, because we need to convert it to give us half over r, which will give us 19 divided by over 2 divided by 2 to get half yearly. All right, and that will give us 19 over 4%, no longer in per annum, but now in half yearly. Okay, so that is the rate we are going to use. Okay, so this is our rate for every 6 months or every 0.5 year. All right, so our N, the number of circles or the number of reckoning, they are reckoning the man's account or the saver's account every 0.5 year. Okay, there are 2 0.5 or 2 halves in one. All right, so that means in 1 year they will record the account twice. Okay, so in 2.5 years, how many halves can you find in 2.5 years? Of course, 1 year will give us 2 halves, another year you're going to give us another 2 halves, making it 4 halves, and the other half is making it 5 halves. So you can say 2.5. So this is N in years, but in accordance with the half yearly, so we divide by 0.5 year, because half yearly means 0.5 year, and of course you're going to have N equals to 5. All right, so this is 5 reckoning. So they're going to record 5 times within 2.5 years. Okay, 5 reckoning. So that is N here. And of course, from our A is equals to what? P into 1 plus R over 100 raised to power N. Okay, so when you now substitute, all right, what is your A? Your A is equals to 240,000, okay, into 1 plus our R is now 19, okay, because of the fraction. Before we come down and multiply the 100, they give us 400, so 19 over 400, all right, now raised to power 5. All right, so, and of course, with your calculator, if you simplify this, you are going to have the amount, all right, to give us approximately, this will give us 302,678. All right, if you simplify this with your calculator, all right, in Naira. All right, so this is the amount approximately, okay? The actual value is about 0.3793. All right, so what are we asked to calculate again? The amount in the bank after investing for 2.5 years. So this is question A, it has been answered. So here is question A, answered. Question B, it said the interest made at the end of the 2.5 years. Of course, our A is equals to I plus P. That implies that our I is equals to A minus P. So we now have 302,678 minus our P, invest the original amount, 240,000. Some of you might be asking, which I do you use? You use the final I. All right. When you subtract this, you can now have your total interest earned by the man or by the saver to be 62,678 naira. So this is the total amount saved. All right. So hope this is well understood. Let's look at another question to also apply in question 3. Say a special bank account pays compound interest of 6% half yearly to savers. Wow. Is somebody confused here? Let's look at question 2. In question 2, a saver deposits 240,000 naira in a bank which pays compound interest 9.5% per annum half yearly. 9.5% per annum half yearly. Per annum half yearly. Per annum came before half yearly in this question, but here we are told it is 6% half yearly. That means the 6%, the half yearly there is in line, is the rate at which the account is being credited. That means every half a year, 6% to be given. Hope that is understood. Now, why this one is every year per annum, every year, which is per annum, 9.5% is given. But account is created or interest is created every 6 months, every half a year. So that's why we now converted this one so that it can be in line, can be compatible with the time account is being, the interest is being created. All right, so that shouldn't confuse you. So this one is telling you that the interest rate is every 6 months. That is the interest rate. Now, to savers, how much does 1 million naira amount to after 1.5 years? All right. Now, the N is in years, while the rate is in months. So we also need to now convert. You need to be compatible because they didn't tell us when the reckoning is taking place. There was no any other condition telling us when the reckoning is taking place. The account is being generated. That means it implies automatically the account or the interest is being generated at every half a year, which is the rate here. Unlike here, it was supposed to be every year per annum, but they change it to say now it is recorded or created. The interest is created every half a year. That's why I have to convert this rate, all right, to half a year rate. So those are the difference between the two questions. Okay, so now our rate is already in half a year. Okay, our rate is 6%. Okay, half yearly. All right, while our P, of course, is 1 exponent 6 million naira. Then what again do we have? Our N, because how many half a year do we have in 1.5? Of course, we have 3. All right, that's a simple math. Okay, so N is equals to 3. Okay, 3 reckoning periods. Because you record the first 6 months, the next half a year making it 1 year, and the next half a year making it 3. So there are going to be 3 reckonings in 1.5 years. All right, so that is well understood. So when I say that our A is equals to P into 1 plus R over 100 raised to the power N. All right, so our A is equals to 1 times 10 raised to the power 6. That is give us 1 million. Okay, into 1 plus our rate, which is 6 over 100, of course, raised to the power 3. Simplify with this with your calculator. You are going to have 1,191,016 naira. So this is what you will end up having as the total amount. How much does 1 million amount to? How much does it amount to? Not the interest. So they're just looking at the amount, both the interest plus the principal. So that is the solution to this question. And please take note, all the places we are using this formula, the principal is always constant throughout the question, and the rate is always constant throughout the question. As we are going to be seeing different conditions also. Okay, let's look at the next question. Okay, let's look at the next question. Now, in question 4, It says, how much will 25,000 naira amount to in 2 years at compound interest if the rates for the successive years are 4% and 5% per annum respectively. So, of course, you can see here, we are seeing a typical example where the rates are changing. So, we now have our P is equals to 25,000. Okay, that's our P. Our P is equal to 25,000. Then what's our rate? Our rate is in per annum, and our N is also in years, so they are compatible. So N is equals to 2, and our rates, we have the first one for the year 1 is equals to 4%. That is for the first year. Okay, year 2 is equals to 5%. The rate is changing for the 2 years. All right. So we now say, what are they asking us to calculate? How much does it amount to? That means the amount, not the principal, not the interest. P into 1 plus R all over 100 raised to the power N. But because it is changing, we don't use this. The rate is changing. So you have to say that your A is equals to P, okay? This will have 1 plus R over 100, okay? Multiplied by 1 plus R over 100. Now, if I have multiplied these two, I could have 1 plus R over 100 raised to the power 2 years. Okay, that's what I have. But because here and here are the same, okay, that's you having a square. But because the rates are different, so I'm not going to multiply. This is going to give us R1 and R2 representing the rate for the 2 years. All right, so when you insert into this formula, our A is equals to P into 1 plus the first rate is 4 over 100. Okay, that is the first rate multiplied by the second rate, 1 plus 5 over 100, the second rate. Okay, putting our P, I forgot to put that. That will give us 25,000. All right, multiply by whatever you now have. Okay, which is 104 over 100. All right, multiply. If you simplify this one also, you're going to have 105 over 100. Now, if you use your calculating device, of course, your total amount is going to give you about 27,300 naira. So this is what you have. All right, so you can see a typical application of when the rate is changing. All right, so we are going to stop here for this episode. All right, I'm going to make the videos short, not to be too lengthy, and also for my students to find it very easy to enjoy and watch at leisure time. So I'm not going to make it too long. All right, so we're going to stop here for episode 2. Okay, in episode 3, I'm going to solve further questions, all right, on compound interest. All right, so if you have also enjoyed this video, please do well to like this video. Recommend this video to students having challenges in mathematics. Recommend this video to schools to use as a teaching material. Also, please do not forget to subscribe to this channel. Thank you. It is a goodbye from me. We meet in episode 3.